Thank you so much for those really kind words, Tali. Let me first start off by saying that I'm really grateful to be here. I don't know if you can tell by my accent, but I actually used to live in Bavaria. Ich liebe Bayern. And yeah, give it up for Bavaria. Munich is probably also one of my favorite cities in the world. In fact, the last time I was here was the first week of October in 2024, which means, if you know, you know, I was wearing lederhosen, and I was standing outside of a massive queue waiting to get into an Oktoberfest tent with my friends. And yeah, if you want to give it up for Oktoberfest too. But while we were waiting in line, we decided to play this game. One of us would think of a mystery country, and the others had to guess that country as quickly as possible. And we could ask any yes or no questions that we wanted to. And the amazing thing about playing this game was not only did it help us pass the time, but it allowed us to truly see which one of our friends were experts on the world and which ones weren't. Because those of us that were travel, history, politics, geeks were able to rip through this game. We could take 193 countries and narrow it down to one really quickly. And so at the time we got to the top of the line, we were really feeling ourselves, so we decided to test AI. One of my friends pulled up ChatGPT, and we wanted to see if it could reason about playing this game better than we could. So DLD, I have a question for you guys. Do you think that LLMs, the darling child of AI, humbled us? Put your hands up if you think that ChatGPT could play this game better than we could. Put your hands up if you think it couldn't. And those of you with your hands up right now, you're ready for the red pill. It performed much worse than we expected. Right off the bat, its first question was always something really vague and inefficient, like, is the country in the Northern Hemisphere? Now, sure, this question sounds smart, but the truth is that out of 193 countries in the world, only 32 are in the Southern Hemisphere. After that, LLMs would tend to fall down these very repetitive rabbit holes, like asking the same type of question over and over and over again, like asking what the continent the country was in for 6 moves in a row, or even sometimes just guessing individual countries until it hit one. All in all, it just felt really unhuman. And this right here highlighted one of the big limitations of LLMs that I'm going to share with you today. In the face of ambiguity, LLMs struggle to form strategies to reach a goal. That's what makes them unreasonable. Now, before I go any further, I'd love to introduce myself to you. My name is Shravan. It's a pleasure to be here. A little bit about me is that I come by way of an applied AI background from Harvard University and Imperial College London, where I taught my class. And after that, I was very lucky enough to be one of the first team members of one of the most ambitious technology projects of our generation, WorldCoin, founded by Sam Altman. Now, I learned a ton from working with Sam, as well as other industry leaders in technology and AI, but I am here in front of you today because there's something about our industry that has always frustrated me. We're far too obsessed with LLMs. And not only that, but we throw around terms like AGI, superintelligence, reasoning, far too casually for my liking. So I'm here today ready to share a controversial statement, but I'm also ready to back it up. LLMs are not the path to superintelligence. And their inability to reason about how to play the country guessing game should be the first red flag. But in a world where we're trying to be future positive, let me tell you, I'm not here to be a pessimist. I come with a solution. And I'm here to introduce you to a new path. Because today, I am the CEO and co-founder of Atman Labs, a London-based applied AI company. And I'm very proud to say that our team, consisting of just 5 of the best researchers in the world, managed to design and build a system inspired by human reasoning that far outperforms LLMs at this task. Not just GPT-4o, but also OpenAI's o1, its reasoning model. On average, these models need between 12 to 13 questions to guess a mystery country, whereas our system needs just 8.38, which, for what it's worth, far outperforms me and my Oktoberfest buddies too. This is the reasoning engine, and I'm really grateful to be able to introduce it to you today. Now, DLD, do you guys like secrets? Because today, I'm going to tell you 3 of them. First, I'm going to share with you what our team observed about how humans reason when playing the country guessing game. Second, I'm going to share with you how we designed and built a new type of AI system to emulate it. But finally, the biggest secret that I will share with you today is how solving the country guessing game is actually the key to solving some of the most important problems in humanity that LLMs can't solve, and will bring our industry much closer to superintelligence. So do I have your attention? Good. Then let's start from the top. The first question that we asked ourselves was, how can humans reason to solve an ambiguous problem? Now, just some quick housekeeping and some definitions. In an ambiguous problem, there is no one fixed solution. So it requires humans to not only be able to form new strategies on the fly, but also adapt as their environment or their surroundings are constantly throwing new information at them. So let's first look at how we solve the country guessing game. When we start the game, we know nothing about the mystery country. However, a really smart human, one that's traveled the world and read lots of books, actually comes with a map of knowledge already in their brain. One that connects various concepts like what oceans the country is near, what languages they speak. Now, this map of knowledge is what we call a world model. And the better the expert, not only are there more concepts that exist in their world model, but there are also more connections between those concepts too. So how does the world model help us reach a goal to solve ambiguous problems like the country guessing game? Well, if the goal is to guess the mystery country with the fewest number of moves possible, then our world model at a given point in time, based on what we know about the mystery country, should tell us not only what are the remaining possibilities that country can be, but also if there exists a relationship that allows us to eliminate a large amount of those remaining countries with a high probability. This leads to the next action we take. And that action then updates our world model, which leads us to take the next action, and so on until we reach the goal. Every action should create less and less ambiguity until that goal is reached. And that's why we believe that the key to this next breakthrough in machine reasoning is emulating the interaction between a world model and taking actions to reach a goal. And we've solved this. How? By being inspired by two historically separate fields of AI. On the world model side, we're inspired by the fields of AI like knowledge representation and symbolic AI. Knowledge graphs are data structures that allow us to literally form this map of knowledge between concepts from any data and provide an elegant structure with which we can reason over. But here's where the magic comes in. On the actions and goals side, we're inspired by another London-based forward-thinking AI company, DeepMind. When DeepMind launched AlphaGo, it introduced the world to a concept called reinforcement learning, where a machine can explore a complex decision space to form goal-based strategies. And so the question we asked ourselves was, what if we could use reinforcement learning not just to explore a fixed game board like in chess or Go, but to explore a knowledge graph, taking actions to form new paths in its world model until it reaches a goal. This represents our eureka moment. This is the core breakthrough of the reasoning engine. And of course, connecting the two was challenging, but when we did, in the case of the country guessing game, the results shocked us. Now, I'd like to share with you how our system works. First, we've built it a custom world model by ingesting data from Wikipedia articles to the CIA fact book of the world. We have formed a knowledge graph consisting of countries and their connections to various concepts, like the oceans they border, shared characteristics of their flags, their development levels. All of these are represented as nodes in the graph, or the dots that you see here. Then to play the game, we have trained a reinforcement learning agent to explore different edges or connections in this graph to learn more about a mystery country. Every edge that it forms, in this case, figuring out that the country is an island country, not only gives the system more information, but it navigates its position in the world model to a different place. This allows it to implicitly filter out countries that are farther away from its current position in its world model. And so it continues to take actions to form new paths through its world model until it narrows in on just one country, in this case, Barbados. By learning to explore its world model, our system has learned how to form strategies that weren't pre-programmed. Every mystery country leads to a new strategy that can adapt on the fly as it gets new information. And we've seen many instances where the orders of questions that it asks completely shocks us and is unlike anything that GPT has ever tried. But on average, it outperforms all of us. So I've told you about what we've created and how we've created it. Now it's time for the final secret. Why does this matter? Well, what we have done is create a system that can form strategies in the face of ambiguity towards a goal. Now I want to throw around this term again, superintelligence. And when you think of superintelligence, I want you to think about this. As humans, we exist in this universe that is constantly changing and throwing new information at us. This is the definition of an ambiguous environment. Yet we are still able to form goals and form strategies and take actions to reach those goals. But if that's not convincing enough, let's dive even further and look at some of the hardest problems in humanity. From a scientist who's running experiments in a lab trying to reach a groundbreaking discovery, to a stylist who's trying to get to know a new customer so he can introduce them to new styles, or a doctor who just had a patient rush into her emergency room, and so she must figure out how to diagnose and treat that patient before it's too late. DLD, do you know what all of these tasks have in common? They all require forming strategies in the face of ambiguity, which leads me to another PSA. The way that we currently benchmark LLMs against superintelligence is flawed. We look at how well they can solve things like math problems or academic tests to see if they're close to AGI. But a math problem isn't ambiguous. You don't need to interact and get information from your environment. And there's a fixed strategy to solve that LLMs can simply just learn and regurgitate. But as we have seen today, LLMs struggle to reason in the face of ambiguity, such as in the country guessing game. And as a result, they can't do any of the tasks that I've mentioned above. But in society, there do exist very smart humans that have historically always been able to perform these tasks better than AI. We call them experts. And we believe that we can extend our reasoning engine and contextualize it to emulate any expert task. To take this a step further, I know we've talked and heard a lot about the agentic web, but I don't think that this is thinking big enough. When you combine the framework of agents and taking actions on behalf of humans, with the breakthroughs in reasoning, we can level up the agentic web to the expert web. How do we do that? Well, our reasoning engine is actually context independent, which means that just by simply connecting it to a different world model and an interface that can perform actions, we can emulate and even supersede any type of expert behavior in the digital world or even in the physical world. Now let's go back to that doctor example. In this case, a world model can be a knowledge graph that organizes and connects various diseases with their causes, their treatments, the symptoms that are exhibited from them, genetic predispositions, and more. And when a patient interacts with our system, our reasoning engine can connect with this world model to suggest actions, whether it's running tests or asking questions, until a goal is reached. In this case, the goal would be that every action should narrow the potential diseases that the patient could have until you narrow it on one. And so it can solve diagnostics better than an LLM could, but it doesn't have to stop there. What if after that disease is identified, the system can predict, administer, and even adapt a treatment to a patient over a long period of time until they are cured? This is how the combination of world models and actions allow us to even reinvent personalized medicine. This is how we extend our reasoning engine to solve the hardest problems in humanity and disrupt industries. And guys, we're already getting started. And I bet you'll never guess which task on the internet we're going to reinvent first. Think about it in your head. Shopping. Now, I can see half of the audience, okay, a little bit more than half, okay, most of the audience, a little confused on how we make the jump from medicine to science to shopping, but I can see a few of you with that sparkle in your eyes. And I bet that these of you guys are the ones that have actually tried to buy an outfit on the internet. Look, we asked ourselves, what is the fastest path to allow our reasoning engine to A, learn to explore larger world models, and B, interact with lots of users? And three things came to mind: scale, need, and opportunity. So I'm going to keep this brief. Scale, billions of people shop online each year. Need, online shopping is incredibly challenging. Unless you know exactly what you want, it's hard to get inspired and navigate through the billions of products on the internet to figure out what is perfect for you in that exact moment. Do you know why offline retail is so much more successful than online retail? Because of personas like personal concierges and shopping assistants that make this process easier. Which leads me to the opportunity. What if every single customer on the internet could interact with their own personal shopping concierge? One that has formed a world model consisting of every product review, blog post, Instagram picture, and where every interaction takes you to explore a new path of knowledge that is relevant and will help you make a decision in that moment. We are going to introduce the world to a new way to shop, but it's part of an even bigger mission. Powered by our reasoning engine, Aura will be the first of a number of products that will disrupt search and the way with which we interact with information on the internet. And it's going to launch later this year. But we're not going to stop there. It's the start of a truly exciting journey. And if there's one thing that you should take away about our company, it's that we operate with conviction. At Atman Labs, we are unafraid to start a new revolution, a reasoning revolution. We're unafraid to challenge the status quo of LLMs at the Superintelligence table. And we're unafraid to launch new types of human-machine interactions across industries using our reasoning engine. But I'm going to leave you with one more thing, another thing we're unafraid of. We are unafraid to be building an industry-leading AI company out of Europe, where the talent and ambition exists to help us realize this vision. But it's time that we stop playing catch-up, and instead we galvanize ourselves to explore and lead a new frontier of AI. So if you're crazy enough to want to be involved in chasing this new frontier of AI with us, let's talk. Thank you.